Okay, so thanks for the introduction. Again, my name is Tianhao Wan, and today I would like to present our work that is using solve the frequent item set mining problem with a formal privacy definition called the local differential privacy. And this is a joint work with my advisor, Professor Ning-Hui Li from Purdue and Professor Sumesh Jha from Wisconsin Madison. So in recent years, we have a lot of cell phones, we have wearable devices, and lots of other devices. In many cases, the companies would like to collect data from all the users, either for making recommendations or predictions, or even for preventing malicious phone calls. But sometimes users are not willing to give their private information to those companies. This is even the case with the new regulation come into enforcement. But we kind of now have a technique that can be used to persuade the users to give their information to the companies, and that is called the randomized response. Intuitively, this is a technique like systematically lying to the companies. With that, every user is kind of not always telling the truth, but sometimes lying, so they feel they are good, they are not sacrificing their privacy. And on the other hand, because this is lying in a systematic way, the companies can still get some utility. And this is a survey technique proposed in the 60s, and now we will go through an example. So for example, the survey people ask every user, do you have a certain disease? And each user will, in this setting, will flip a secret coin, and we assume it's an unbiased coin, and if it comes up head, we will answer the truth with like 50% probability, and if it comes up head, it will answer randomly. So the good thing about this protocol is that it provides what we call the deniability. So informally, this means seeing the answer, no one is able to tell the truth. And also this can be easily extended to handle more general setting where, for example, each user, there are more possible answers, and we formally call it the setting of local differential privacy. So specifically in this LDP setting, there are many users and a centralized server or aggregator. Each user has private value and wants to send some information or what we call noisy data to the server. So in this setting, because the data is first perturbed and then sent to the server, therefore the trust boundary for each user is very limited. Specifically, there is a perturb function P that takes value V from a specific domain, and it will output the value Y, which we call the report to the server. And we say that the function P is epsilon LDP if and only for any two values V and V prime from the domain. The ratio of the probabilities those two values are perturbed into the same output is bounded by epsilon. And smaller epsilon means stronger privacy. On the server side, there is an estimation function that takes all the users' reports and output the estimated distribution of any value in the domain D. And we call this protocol a frequency oracle, and there are many other frequency oracles proposed in the past, and we refer to our paper in UC 17 for systematic survey and other frequency oracles. And also in the industry, we have seen many deployment. For example, Google's deployment with the Chrome browser, and Apple is using it to collect information from iPhone and Mac OS. And I think Microsoft is also deploying it from last December or sometime. So in this paper specifically, we want to solve the problem of frequent item set mining. And yeah, so this problem can be used for association rule mining or prediction and other things. So specifically in this setting, each user will have a set of values. And each user will also report with LDP to the server. And the goal is to find the most frequent singletons and the most frequent item sets. So for example, in this setting, there are 5 users, and each user have some set of values. And the top 3 most frequent items are E, A, B, and the top 3 most frequent item sets are EA and AE, because AE appears in 4 of them simultaneously. So to solve this problem, a strawman method would be to encode each possible item set into a value in a very big domain. So here, the domain is pretty big. So the problem, this solution cannot scale with the larger D. And also, if one item is frequent in many infrequent item sets, because each user reports the item set only, this item cannot be captured. Yeah, so with that, we have the challenge. The first one is that each user now has multiple items, and another is each user's item set is different. So to solve this problem, one technique we can use is what we call pad and sample-based frequency oracle. So in this frequency oracle, each user's item set is different, and each user will first pad it into the same size with the dummy items. Now each user has L items, and will sample at random one item from this item set. Then the user will do what randomized response or frequency oracle will do. The user will report to the server, and the server will aggregate and find the estimated distribution, and we'll multiply the results with L, because each user sample with L. Yeah, so the idea of this function or this technique is that when many users have the same item, it will sample very frequently so that the aggregator can capture this signal and have that as a result. So one existing solution to this problem is called LDP miner in CCS 16. There are 2 phases in this problem, in this solution. In the first phase, the goal is to find the candidates of the most frequent singletons. Specifically, each user will first pad its set into size L, where L is the 90th percentile of the size distribution. Then each user will randomly sample one and then report. At the end of the first phase, the potential 2K most frequent items are returned. And in the second phase, where the goal is to estimate the frequencies, each user can intersect its private value with the 2K items and then pad to 2K, because the intersection is at most size 2K, there is no missed items here. And then each user can randomly select one and then report. However, this solution could not handle the frequent item sets mining problem, and it can only handle the item mining. And because it does not choose the optimal parameter, and we have the 2 observations here, we will increase the utility of this solution. Yeah, so the first observation is that there are 2 sources of errors. The first one is the variance of the frequency oracle. That is because each user has to perturb it, this perturbation will introduce some noise. And also the noise will, the variance will increase quadratically with the size L. And another is, as you may notice, there is an underestimation effect. So the last user has 6 values. Each of them will be sampled with the probability 1/6. But in the result is multiplied by only 5. So there is an underestimation. The intuition here is we want to trade off between the two sources of errors so that the overall error will be minimized. But that depends on the goal. For example, if the goal is to identify the frequency oracle, if the goal is to identify the most frequent items, we have two kind of options. One is to use a fairly large L, and another is to use the smallest L. So we noted that the option to our left is okay for frequency estimation, but for identification, some users may report dummy because some users will pad dummy items to his private value. So this makes the signal very weak. And on the other hand, the option to our right is more stable because even if it has some underestimation effect, the relative ranking of the items are pretty stable, so that the overall result is it's better in this setting because the signal is stronger and the ranking is stable. We also have another observation we call privacy amplification effect. So in this observation, we already know that LDP will bound the perturbation. For example, in the randomized response, we have this ratio. But with the sampling, things will be different because each value will be sampled first, and then, each value will be sampled first and then perturbed. So we can see the equation to the bottom is different. So therefore, we can use larger epsilon in the right of the screen. And so as a result, we propose to adaptively choose the better performance frequency oracle based on the overall variance and based on the improved privacy epsilon prime here. So our protocol, we call it SWIM for set value item mining. So it looks somewhat similar to LDP miner, but has some key difference. One is that in the first phase, each user will sample one value without any padding. And in the second phase, we want to find the 90th percentile of the new intersections. And in the third phase, each user will pad to L, which is the 90th percentile, and then report with this adaptively chosen frequency oracle. And so, yeah, this is the diagram of our protocol. And notice that the two steps to the bottom are for Itemset mining, which for the time constraint, I will not talk in this presentation, but it will be in the paper. And as a highlight, it will perform better than the LDP miner. So yeah, finally, there are some experimental highlights. We use the POST data set, which contains like thousands of different items, and we compare with the LDP miner, and also some improved version of LDP miner in order to highlight what are the key features that leads to the performance improvement. So this is one result of identifying things. We use the F1 score, and the x-axis is the epsilon, which is smaller the better. Y-axis is F1 score, the higher the better. And there are six kinds of competitors. The first one is LDP miner, and we have some improvements over it. And finally is our swing protocol. And we can read some scores from it, and also we can see the interesting point, and the big jump comes from if we use adaptive instead of some fixed frequency oracle. And we can also see this similar effect when estimating the frequency of those singletons. So finally, to conclude, this paper consider the problem of finding frequent item set and frequent singletons. The main takeaway in this paper is that when we use some frequency oracle in some setting, we'd better examine it carefully instead of using it as a black box. And yeah, we also cover item set mining in the paper, and I look forward to see you in the post session tonight, and I will take any questions if you have. Thank you.
So we have time for some questions. Please come to the mics. So one question I have, the fact that you are now mining also the frequent item sets, does that reveal more information about the frequency initially? Because you're kind of gathering more information about the system, and then I wondered if there is no side channel that has these two quantities and reveals more information as if you were not actually mining those.
I see. So first of all, we have the LDP definition, which is a mathematical bound. And another key factor is that each user will report once to the system. So if we also do frequent item set mining, we will ask another group of people. So we partition the users into many groups.
Okay, that makes sense. Do we have more questions? So does that mean that if you were actually asking the same users, you would be leaking because of correlations?
Yes. If we ask the same user 2 questions, we need to double the privacy budget, which is bad.
Okay, so do you expect your system to be actually used by Google or Apple or one of these?
Yeah, we hope so.
Have you talked to them?
No.
Probably Ulfar was around, maybe. Okay, then let's thank our speaker.